Hey everyone, I'm Aman Bhavani, software engineer by profession, and I solve coding interview questions. To know more about me, check out my LinkedIn profile mentioned in the description. Today we are going to solve fourth question of our sliding window playlist, longest substring without repeating characters. The given description is pretty straightforward. You are given a string S, and you have to find the length of longest substring without repeating characters, or longest substring with distinct characters. For example, we are given a string S, and we can see that A, B, and C are the longest substring having distinct characters and its length is 3. In the second example, the given string contains same characters, hence the longest substring length will be 1. In the third example, WKE is the length of longest substring and its length is 3. One thing to notice is PWKE is a subsequence and not a substring. That is PW and KE over here. So though it contains distinct characters, but it is not longest substring, it is the longest subsequence. Now, as I've mentioned in my playlist introduction video, this problem we are going to solve by using optimized sliding window technique. So let us start with the solution. Just like previous videos, even here we are going to use similar dynamic sliding window strategy, and also we will use hash map to remember the last index of each character that we have processed. Now, whenever we get a repeating character, we will shrink our sliding window in such a manner that it will always ensure that we have distinct characters in the sliding window. So let us go through the code first, and then we will understand with the help of an example. So we will do some negative testing first. If S is null or if the length is 0, then we will simply return 0. Now next we will define the hash map so that for each character it will remember the last index position for that character. Then we will initialize our start pointer and the max length, which will be our answer. Now we will write a for loop so that it will iterate from 0 up to the length of the given string S. Then we will initialize our right character. Now if our map contains this right character, then we have to shrink our sliding window. Now this if statement will always ensure that we have only distinct characters into our sliding window. Well, it might be confusing for now, but we will understand it much better when we'll go through an example along with this code. Now, if our map doesn't contain that right character, so we will simply update our max length by comparing with the window size, that is n minus start plus 1 with the current max length. In the end, we will put that right character into the map and map it against the last index. Once we finish this for loop, we will simply return the max length. Let us try to run the code. Now, before submitting, let us go through one example and understand the code and its approach in detail. Let me zoom it a bit so that it is clearly visible. Okay, so this is our given string. I've initialized the start variable and the end pointer that we are using into the for loop, our max length, which will be our final answer, and the hash map. So to start with, start and end both are at point 0. So right here will be A. The hash map doesn't contain it. So we will update the max length and we will put the right character into the hash map. Okay, ideally max length should be 0 first, and now we have incremented to 1. And in hash map it will be A comma 0 only because end is still at 0. Now we will increment E. So now right here is again A, and this time map contains that right character. Now according to this if block, if map.get right here, that is 0, is greater than or equal to start 0, then we will increment the start pointer. So our start pointer will become 1 now. So it is pointing there. Next, we will update the max length if required, and we will put the updated right character and its pointer position. So the character is A and its position is 1. Max length will still be 1. Next, we will increment E. Our right char is B. We don't have it into our hash map, so we will put it into the hash map and update the max length. Next, we increment N2, third position. Our right char is C. We don't have it in our hash map. We will update the length and we will put it into the hash map. Notice how we are maintaining the index position of these characters into our hash map. Now again we increment E. Our right char is C again. Now we have C into our hash map, so we will go inside this if block. Now again, according to this if block, map.get right char, that is 3, is greater than or equal to start, that is 1. So we will update the start by map.get right char plus 1, that is this 3 plus 1, 4. So our S pointer will move directly over here. Now if you see, the S pointer has moved directly from 1 to 4 and it has skipped these position in between. And this is why we call this approach as optimized sliding window. One can easily solve this problem by using hash set, because hash set does not contain duplicate, and that is exactly what we want in this problem. But in that solution, we require 2 times n steps to perform. So instead of using a set to tell if a character exists or not, we could define mapping of character to its index, and then we can skip the characters immediately as soon as we found the repeated characters, like we did over here. So that was it for the explanation. Let us submit the code, and it's a success. So I hope you understood the solution and its explanation, and do let me know in the comment section if you have any queries. Also, like, share and subscribe this channel to help me solve more problems for you. Thank you.